So reactivity, I think it's an overused term. There are many definitions. So who is an Angular developer in the room? So I think most of you, if you heard reactivity, you think about RxJS. But I'm not going to talk about RxJS. I am rather looking into a concept of reactivity that is best described with something like this. When I have an Excel table here, then I describe that I want to have the sum in this field. And once I have declared this, then the behavior of this field is defined. I can go up here and, for instance, say, okay, I have another value. And then the cell down there, it reacts on that update. That's more or less the mindset that's important for us for this talk. So I'm on a very tight schedule. Let's see what I want to do. I will want to give a short intro. What are we talking about? Then I want to do code examples in 4 frameworks, which will be tight. And then what is your takeaway? You will not be a better Angular programmer, a better React programmer once you have seen my talk. But I hope that you will have a glance over your world. Maybe you see some aspects of other frameworks, and maybe you understand the concept of reactivity a bit better when you see the different concepts that these frameworks are implementing. So why these frameworks? If we look at some surveys, this is state of JS, then we see there are other frameworks which seem to be more interesting if we at least look at the people who are answering this survey. So Quick would be interesting. There was a talk this morning, and Solid is very interesting for this reactivity discussion right now. It is a framework that actually has a lot of influence on other ones, for instance, Angular. But if we look into usage, then we see these 4 frameworks are the top 4 used frameworks, and the Angular developers prove that right here. So let's begin. The topic is especially hot right now because Angular has announced a month ago that they will introduce some new reactive primitives in the framework. So I hope that we get to that in the end. I have an example for that we can then also understand how Angular will be approaching that topic in the future. But let's begin in the beginning. In the beginning, there was darkness. And then the DOM was created. And then we started manipulating the DOM. jQuery was of that age. We had a library that allowed us to manipulate the DOM very efficiently, but we ended up with a lot of spaghetti code with that. And these were the dark ages of the DOM. But there was a new hope was born for a first generation of frameworks that's coming up. And they introduced a new concept in the front end, in front-end programming. It was an old concept, but it was new for the front end when we came from jQuery. This was model view controller. And the important thing here is the model view separation. The model view separation, it's implicated that we should not manipulate the DOM. The DOM is manipulated. Oh, I should not have this presentation. The DOM is manipulated by the framework. So that's the reactivity we are talking about. With these new frameworks and the current frameworks, we have state, which is in JavaScript. And this state is the source of truth, and the DOM is just a reflection of that state. That's the view. And then we have actions which can manipulate my state. The action can come from the user. He interacts with this application, or it can be some timeouts or some AJAX requests which come back from the server, and they manipulate my state. And then the framework reacts and updates the UI so that it reflects that state again. That's very different to jQuery, where the state was the DOM, and we manipulate the DOM, but that was the state of our application. Now we have the state in JavaScript, and we want the framework to react if that state is changing. So we could also talk about that the UI is basically just a transformation of the state. And the interesting question now that we want to dive into in code examples is, when is this function called? When is this transformation happening that transforms my state to the representation in the UI? And that's basically what all the modern frameworks are doing. And that's also one of the major difference is how the frameworks are actually do that. So let's go into code. We go to Angular, React, Vue, and Svelte and look at how they do that in a simple example. I want to start with Angular. This is a simple Angular CLI application. I have a simple component structure here. You see I start with my app component. My app component just renders a screen component. The screen component just renders a counter component. And we end up here in the counter component. Now I want to introduce some state in that counter component. So that's, let's say I'm a very naive developer. I just approach it like I would do it if I would be a Java developer, for instance. I say, okay, a component is a class, so a class can have a field. So let's introduce a field, give it a value, and then use that field here up in the template. And it just works. Well, that's nice. That's a nice characteristic of Angular. It just works. So let's go a bit further and manipulate that state. So I introduce a button. Let me type, please. So, and then a handler. Increase. Call that, and then I just manipulate that state. So I say each time this increase is called, I go in and say count should be increased by 1. Let's see if that works. Oh, nice. It just works. Nice. So let's even be a bit more aggressive. And for an example, then for the discussion, let's introduce a constructor. And in the constructor, I'm actually scheduling a set interval. So I'm just a naive JavaScript developer. I know there is a set interval. I just use it. And I hope the Copilot would help me, but I don't have Wi-Fi. So this.count plus, and then I have to schedule that thing. And if it let that run, it just works. That's very nice of Angular. So this is really an intuitive approach to that kind of reactivity. I just manipulate my state as I'm used to if I'm an object-oriented programmer, and the rest is done by Angular. So the question is, how does that work? How does Angular actually know that I have changed my field here on the instance of that component, and it should update my DOM up here? And the key here is, I'm talking about the set interval. This set interval is probably not what you think that it is. So I said I'm a naive JavaScript developer, so I think this is set interval that's coming from the window. Every browser has an interval, and I can call it. But actually, if I've loaded Angular, this is not the case. So let me demonstrate that. I have in this same application here, I have a little demo page. So on that demo page, nothing is loaded already. Nothing is loaded yet, so I'm just going into the console and I'm executing a statement like that one. So that should be obvious for us as JavaScript developers. I'm just assigning the set interval, which comes from the window, to my local variable here, and then I can check. And obviously this is true. But now I'm going to load Angular on that page. I'm not doing a page refresh. I'm just loading the scripts that are usually loaded when I load Angular. Duck. Now I have the same application again. But if I go now here and do the same statement again, oh, the set interval is not the set interval it was before. So Angular does some magic here. Angular patches the browser. Set interval, all events, promises, everything is patched by Angular. And that's the way how Angular finds out that potentially something has changed. So in my case, I'm calling set interval in my code, but it's the set interval that comes from Angular. And Angular then knows, oh, potentially something has happened now. So I'm going to check if something has checked, if the state is still represented in the UI, and if I find out that something has changed, I will update the UI. So that's the model we have in Angular, basically. We write plain JavaScript, which is very nice, but Angular wraps some methods in the browser, which then allow Angular to trigger the change detection, and then Angular says, okay, I'm going to check if the thing that I rendered last time into the DOM is still the thing that's represented in my state, and if I find out that something has changed, I will update the UI. So let's talk about two specific things in Angular, and then compare that way with the other frameworks. So one thing I want to talk and then also compare with the other frameworks is mutability. So if I'm here and I have my state, let's call it state. This thing should still be working. So, and now I would not like to have a primitive state like a number here, but an object. So let's go in and actually say, okay, I have an object here and a count, which is 1, and then I would also have a name, for instance, something like that. Then I still can go with Angular. My naive approach of how I program with JavaScript, it just works. I can say I want to increase that count, I want to increase that count, and I want actually to render that count. And it works. It counts up, and if I push the button, it just works. So Angular, in this kind of model we are using here, is also dealing very well with mutable state. I can just mutate objects, and Angular will find out. The other thing I want to discuss is the change detection mechanism of Angular here. And for that, we are looking into the whole component tree. So if I'm going in now and I have this name, and I'm, for instance, would implement a getter for the name, just for the sake to demonstrate something, I say get name, and I return this dot state dot name. And I log each time this getter is accessed. Count. And then I bind that name, for instance, up here, and I say, okay, I want to show that name. Then we see this get name is accessed, obviously, each time the state is changing. I'm clearing here. And still that getter is accessed because the counter is increasing the whole time. This would not be necessary. The counter is not changing. The name is not changing. But still, in the way Angular works in that mode, it just checks everything. So it says, I have rendered the name, so I'm going to check if the name is still the same. If it's still the same, I will not update the UI, but I will check that. So let's take out the set interval to investigate a bit further. So if I take that one out, then it's obvious only when I click this is happening. Now the interesting thing is when I go into my screen component and I add some more counters here. Now I have several counters on my page, and now I click increase on one of those counters. Only the state of this one counter actually changes, but it still checks every counter component if the state has changed. And even worse in that regard, if you go to the app component and also you have a getter here for title, and we would also bind that title in a template, so even if I change the state of one counter only, the app is checked if it has changed. So that's what we call also change detection cascades. That's how Angular currently works. It executes too much code that it had to, just to get the changes that it really has to get. So it doesn't miss them, but it also could be optimized. And there are ways to manually optimize that. I don't have the time to go into that. There are obviously, you are the Angular crowd here, there are obviously ways to switch change detection to on push, or then also make reactive state management with observables, even go to zoneless stuff. We don't have the time to do that. That's the state I want to stop with and now compare the other frameworks with that. Any questions so far? So let's compare it with Angular, with React. So let's go in the React example, exactly the same example here. Oops, that's not what I want to do. So I still have the same example here. I have an app component, which renders a screen component, which renders a counter component. And let's dive into here. So now let's see how React helps me, or how tolerant React is with my naive approach. So I do a naive approach again. So maybe the first thing that's a bit strange is this is a function. And we are dealing with states. And a function basically starts and ends, and then it is over. So where is the state? That could already be an alarm sign. From the perspective of transformation, this could make sense. React says, my component is actually just a transformation from the data into the UI representation. And then transformation is modeled as a function. That's intuitive. But where does the state come in? So let's approach it in a naive way. I'm going in and I say, okay, I have let count equals 1, and then I want to show that. Oops, I'm not in Angular. Single braces. So it works. So far, so good. But now I want to have my button. And I want to increase that button, that count. So now I have my button here, and I click increase. And you see, JavaScript tells me, yeah, the counter is increasing, but the UI is not rendering it. So obviously in React it's not that intuitive as we had it in Angular. React is somehow different. How React approaches state management is actually, React says, I'm responsible for the state, and you as a programmer, you have to come to me and ask me for an API to manage your state. So we get APIs from React to manage our state. So I can use that API here, use state, and say, hey, Angular, hey, React, give me the possibility to manage an account. So I'm going in and I'm saying, okay, use state. I say the initial value of that state should be 1. And then I'm going in and I say, okay, I have this representation here in my state, my count and my whatever that is, set count. You can copy that from a tutorial, but now we look at it a bit. So now I can render this count down here. It still works, hopefully. Save on that side, please. Still, I see that count. If I initialize it to another value, I should see the effect. Okay, it is here. And now the interesting thing is, what is this one here? So for those who are not familiar maybe with React, React gives, the use state gives me back a pair, but we don't have pairs in JavaScript, so it gives me an array with 2 elements. And I destructure that array and initialize 2 variables, count and set count, in my program count. Set count is a function that I can call. TypeScript also helps me here. I see from the typing point of view, this is a number, and this is some kind of dispatcher, something, blah, 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 which is basically the type representation of a function here. So I can call setCount. And then I can tell React, please increase that value onto a new value. So, and now this should work. I start with 2, and each time I click that button, I see the UI represents the new state. So I have to use React to manage that state. I have to use the API. Interesting aspect, I don't know if you looked, I click once on the button, and it says to me count is 7 on the JavaScript level. So this log statement here says count is 7, but then later on I have the 8 in my UI. So the interesting part that's happening is here, this render counter, which is up here. So after I have told React, please increase that count for me, React then re-renders my whole component again, and it goes here through, and now React knows this is not the initialization of the component, but the re-render of the component. So I just ignore this parameter here, but I give you to the programmer, I give you the state that you have given to me up down here. And now I re-render the whole world based on that new state I have. So actually this here should be called setCount, then re-render. This would be actually describe what we are doing. We are setting the count and we're triggering a re-render from React. Questions so far? So now let's compare it again with the example from Angular. What happens if I go in and I actually say, okay, my state is a bit more complicated here. I want to have an object here. So this has a count, and it has a name. So then I would have to go in and say, okay, I want to have this count.count. Let's stay with that. I should have called it state in the beginning. And then here I want to, now this should still work. It initializes to 1, but what am I doing here? So maybe I just go in and I say, okay, I have my count, which is the state, and I want to increase it equals 1, so something like that. So I can maybe then give that out, count.count. And then I have to call the API, so let's just give it the count again, the state here. Should that work? Let's see. Again, I see from the side of JavaScript, the count is actually increasing, but the UI is not re-rendering. So React is not, as Angular, tolerant to mutations. React forces me into a model of immutable state management. That means if I want to change the state, I don't change the state of objects. I create new objects which represent the new state. So what I have to do here now is actually say I want to create a new object which represents my state. This is a new object. I clone the existing state into it, and I change that aspect of the state that I want to have changed. So for instance, the count should now be, this is going to be a bit verbose, and there could be a more compact syntax, but for the understanding should be this one. And this is now a new state, and now I give that new state to React, and now it's working again. Then I want to go into the aspects that we had with Angular, with this cascading change detection. We have something similar in Angular, in React here. That is a re-rendering cascade. So we see there is this counter is rendered. We don't have exactly the same effect as in Angular. So if we would go onto the screen, and on that screen here, I would render several counters. So now I have several counters here, and I increase the state of one of those. Then only one counter is re-rendered, not every counter. But if I change state higher up in the component tree, like here in the screen, I have, for instance, can I introduce a state here and then change that state, and I have here an input value, and then my name is something like that. And now, if we look into that, each time I press a button in that input field, you see every component, every counter component below the screen is also re-rendering. So I have a similar cascade as in Angular with the change detection cascade. I have also in React, it's a rendering cascade. So if I change the state somewhere up in the tree, everything down will re-render, everything below it. So let's look how in my picture this looks like. Now in my picture we have this model here. We have the set interval. This time the set interval is actually what we think it is. It's just JavaScript. But we need then to manage the state. The state itself is not just JavaScript. That's something that's managed by React. So it's a bit inversed as the model we had with Angular before. Questions? Let's look into Vue. Same example again. This is an app component, a screen component, a count component in Vue. In Vue we have these templates and scripts. And in the script I can define on top level the scope, and the top level scope of this script is exposed to the template. So I can go in and I can say, let state equals 1. And then up here I want to implement my counter, display my count. And it just works. From that approach here, it's still intuitive, but also here, if we would now go the next step and do it naively, I have my increase button. I want to have a click handler for that increase, which triggers increase, and then I expose a function. And I say state equals state 1, something like that, and I log out that state. Then if I click increase, then you see the state is actually from the perspective of JavaScript, it is increasing, but the UI is not re-rendering. So also here in Vue, we have to go to Vue and actually leverage a feature of Vue to get reactive state. Reactive state, when it is bound to the template, it will then re-render that aspect of the template. So how does that look like in Vue? I have to use an API, and one of those is reactive. And with reactive, I go to the object already. I say I have an object, it should become reactive. This has a count, which is 1. This one I have to import. And now my state is actually a reactive state. So up here in the state, I can access the count. And then I can actually increase the count, state.count equals state.count equals state.count plus 1. And this should now work again. So we get the concept of reactive state from Vue. We cannot just use plain JavaScript for the state. How does that look like when I display it here? We have this kind of reactive state which gets us from Vue. I can wrap it somewhere in JavaScript, the set interval, and this would be plain JavaScript, but then I manipulate this reactive state and Vue goes in and updates the UI. Let's look at the aspects we have looked into React on Vue by looking. So obviously it deals well with mutability. I can mutate the count. Let's look at if we find some kind of cascade. For that, I'm going to have a get function here, function get name, which would even be constant. So, and then return Jonas, for instance, something. I want to display that state here, and that name. So we would see my name here. But if I render that for the first time, we should, I didn't log out here. If I do log out counter get name. So we see for the first rendering it is actually logged out, but it's now, if I change the state, it is also logged out. So obviously I just changed the state, the reactive state, I increased the counter, but still the template evaluates again that get name. So it doesn't look quite so much different. But let's continue with our example. If we are here now and have several counters and look at the output, then we see as soon as I increase, only one get name is called. And if you go up in the tree, somewhere here, for instance, I have a title which says the Vue demo up here, and if I would make it able to change that title, then we see that the counters are not re-rendered. Vue knows that only this one here is re-rendered. So Vue doesn't have these cascades. Vue has something that's called fine-grained reactivity. So Vue has a direct relation between the state, which is accessed and then changed later on, and the component that has to be re-rendered. How does Vue actually do that? Vue does that by Vue knows when a component is rendered, and Vue is in control of the reactive state. So when Vue starts rendering, it tracks who is accessing that reactive state. And by the access, it knows who is dependent on that state. And then later on, if somebody is changing that state by calling a setter, then it knows, oh, I have some other pieces which depend on that state, so I have to trigger them again when the state changes. And that's called fine-grained reactivity, or the fine-grained reactive state, basically, which allows Vue to avoid those cascades that we have seen in Angular or that we have seen in React. It even goes further. In Vue, I can go in and have a simple JavaScript, no Vue rendering and no Webpack, no bundles, not whatever. I just have an HTML file. And in that HTML file, I load Vue, I load an app script, and in the app script, I just use that reactive API of Vue. And I say, okay, I have a watch effect function which updates my body. And I have reactive state. And if I load that here in the browser, just plain, then you see this is counting up. And also giving me some, no, it's just counting up. So you see, this changing of the state here in that interval, because the state is reactive, will rerun that effect. So changing the effect changing the state has a side effect of running this code here, which updates my UI. So this also allows me to take out the state entirely. So if I go here, and I have in my counter component, I had my state like this reactive here, I can also go in and say, okay, I want to have this state from something that's living outside of Vue entirely. And I can just say, I give this reactive state to the component, and then I change that reactive state, and the component would still update. So changes to the state are actually the driver of UI updates, and not that the state just leads to a re-rendering of a component and then this drives the update. So the state triggers a re-rendering of one component in that tree, and only that component is re-rendered. Still, the whole component was re-rendered, so we have seen that the getter was still accessed on the same component, but it is much more fine-grained at the runtime. Questions so far? Let's go to Svelte. Svelte has one more concept, or has quite a different concept. It does reactivity via a compiler, and it's a bit more difficult to show. But let's try. So I'm going here. I'm going here. So that's the Svelte example. Again, app component, screen component, counter component. I'm going to the counter component. I have a script and a template. I want to have my counter. So I just go in and say let state equals 1. And then I want to show that. What did I do? Thank you. So I have this one, and I continue with my example. Thank you very much. I want to have the button increase, and then I want to have the click handler. No, I have a blackout. I have to go to my script. Let's go this way. So, the on, I forgot. We are here. On, click. And then I pass the function increase. And I write a function. And then intuitively I also go in and I say state equals state equals 1. And this just works. So I think I would argue this is also quite intuitive. We go a step further. We say state is actually an object, count 1, and name. And then we say state.count equals state.count plus 1. And here we want to render state.count. It still works well, so it embraces mutability if I want to. How does that work in Svelte? So Svelte is a compiler basically, and everything that's a variable that's declared on top level scope of this component scope script here, where it is assigned, it will actually generate reactive code which updates the UI. So if we investigate a little bit further and have something like that, this is the Svelte REPL. We could also look into the generated code in the browser tab, actually in the browser debugging tools, where we see what's actually loaded from the as JavaScript code. But then we see this kind of code, similar to what we just implemented. This kind of code leads to that code at runtime. And if we start to investigate that, then we see something like that going on. It's probably a bit small to see that there is actually code generated which updates the UI even more surgically than we had seen with Vue. With Vue, we had a tracking between a state which is changing and then a component somewhere in the tree is re-rendered, only those components that need that state. Here, the components are not even relevant at runtime anymore. They are compiled away. We just have a dependency between some state which is changing and then a UI element, the DOM element, which is updated. So if you would then look at the slide and follow that, maybe you see here is some kind of invalidate function that's generated because I'm setting here a name. Then we see an invalidate function is called, and this invalidate function then goes through an update function, but this update function actually updates directly a DOM element. So there are not components at runtime anymore. The compiler eliminates the components and just generates code that tracks state changes to DOM updates. And that's what they call true fine-grained reactivity. If we look into the community, this is mainly driven by Solid right now. Solid is a framework that claims to have this true reactivity, and they argue components are not relevant at runtime anymore. They're a good thing to organize your code during writing the code, but at runtime you don't need components anymore. And that's what's happening here with the compiler. So we have a direct relation in that model between the state and the DOM, and components, they just disappear. So let's come back to Angular. So Angular actually introduced or will introduce new reactivity primitives. They are called signal. And this can be terrifying because it's another option how to manage state in Angular. And we will see how it evolves. It's already there in the preview version of the next version. I'm not sure if it will be stable in 16. I don't think it will be stable, but it's already there, basically. So let's have a look at it. But for that, you have to help me a little bit. So please, everybody, squint your eyes. Really, really small. And look at the screen now. Really squint your eyes. This code here should look familiar. That's what we did with Vue. Oops. So still squint your eyes. Now we have Angular code. It looks quite similar. So those signals actually, they're quite equivalent to what we have with Vue. We have this reactive state from Vue. Signal gives me a reactive state, and then I can change that reactive state and I get some APIs from Angular. Up there we would see them like this computed to have derived state, which I computed the double count here, and then also. So, and also the effect which runs something when the state is changing. So this actually works. So if we go in the Angular example here now, the last example that I have, you see that code here. Again, my counter component. And in my counter component, I define my state with a signal. I say, I want to get some state from Angular. Now I cannot use just plain JavaScript object. I have to go to Angular and say, I want to have state in the representation of that signal. This count here is a signal. And then I have to access that count as a function, as a state. Also up here in the template, I have to access as a function here. And then I can actually change it. There are different ways to change it. I can go in here and say, this is the new value that's represented by that signal by just passing in a new value. And then I have an update, which allows me to update an object, or a mutate, which allows me to mutate objects. So we have both models, mutable and immutable models with the signal. And this just works here in that case. So that will be a new API that we get from Angular. So let's look how far they are with the implementation right now. If we look into it, and we also do some kind of a title, for instance, which I show up here. This counter component is shown up here. I log that out and access. Then we actually see it didn't change much up to now. So if I increment it here, still the getter of that name is still accessed each time. So thank you, time is over. Please have some 1 minute. You see the the getter is still changed. So they did not yet change how the change tracking is working. We still have that cascade stuff, but with that signals, they get the option to go further and do the same thing that Vue actually does, or even what Svelte is doing. So in the extreme case, they can now optimize because the signal is reactive. So they can actually tie then the changes of the signal to actually a DOM element if they want to go there. And then they wouldn't have to have this whole change tracking anymore through the whole component tree. And the other one, they could actually get rid of that patching of the browser because the state changes itself can drive the DOM updates, and you don't have to just realize, oh, something has potentially changed. I have to check if something is really changed in the state. So this opens a lot of possibility then to improve how change tracking is working in Angular in the future. But of course, there are also many questions how this will be picked up in the community. So one of the big questions is, what's the role of RxJS anymore? What's the role of change detection on push? Do we still need that? If we go all in with signals, we don't need on push anymore. How will they get rid of Zone.js? Is there some kind of migration strategy that some parts will still use Zone.js, other parts will not Zone.js? So time will tell how this will evolve in the Angular community. So that was my talk. I hope you have seen some stuff that you haven't seen before. I hope you have fun with your framework of choice. All the code examples and the slides are in a GitHub repository down there. Thank you very much. Any questions?
If you would have as much time as you want, and you could start, you would start a startup, and you would build a front end for a medium complexity customer-facing front end. Which framework would you personally like to choose and you like to work with most?
It's a difficult question because I have a history. So myself, I'm feeling most comfortable with React. But on the other hand, I think it is not a relevant question because I don't think that your startup will fail based on your front-end framework decision choice. I think they are quite similar anyway. They are building single-page applications, and if the model of single-page application does fit your use case, then you can do everything with all of those three. And then there are other questions like how big is the market of developers that you can tap into and stuff like that. But from a technical perspective, I don't think there is a much differentiating factor between those frameworks. Of course, if you go into the future and look into rendering models that we had in the quick talk this morning also, the frameworks promise different things in the future. So I think that there is a big trend going on that many of those front-end frameworks also go back to the back-end and have server-side rendering models. And for instance, React Server Component if React Server Components will have enough momentum, it will have a big influence on the front-end community, I think, how architecture will look like in the future. But right now, I don't think it's if you are building single-page applications, the choice between the framework will not kill or be a success factor of your project, is my opinion. Yeah.
Are you aware of React using signals as Vue is already?
There is a port, so Preact has signals, and there is a port from Preact to React, but I've not looked into it, and I would be curious because I would be not too fast because I think, as far as I gather from the React core team, they are not going into the direction of signals. They don't. This is quite another mindset. The mindset of React is we always re-render everything. And Signals has this fine-grained approach where you say, we don't have to render everything. And this is a bit contrasting. And I don't think React is going into Signals right now. So, thank you. The time is up. Another speaker will be coming.